Hello everyone, this is S.Y.B.Sc working as an assistant professor at Department of Physics at HM College, Nasa. Today we have to going to discuss S.Y.B.Sc paper 2nd semester 3 instrumentation, and today we have to cover up the first topic of transducer, and in this topic we have to cover up the subtopic of classification of transducer and its characteristics. So starting with a transducer. What is a transducer? So transducer is a device which converts primary form of energy into a corresponding different energy forms or corresponding signal with a different energy forms. That is the known as a transducer. A transducer is a device primary form of energy into a corresponding signal with different form of energy conversion. That is the known as the transducer. The primary signal form are physical, magnetic, chemical, thermal, optical, mechanical, radiant, and electrical, which are converted into a measurable form, most of the in electrical form in terms of current, voltage and resistance. So the example like as a mic, speaker, microphone, photodiode and solar cell. So these are the some examples of the transducer which converts one form of energy or primary energy to the secondary energy, like as a mic. It converts your voice into a speaker. So it converted into a electrical signal. Second one is the classification of transducer. So classification of transducers are divided into in different ways. So this classification is depend on their application, energy conversion, output signal, electric principle and parameters used and principal pressure. So these parameters are gives the classification of the transducer. So the transducer can be classified by following ways. First one is on the basis of the transaction form used. Second one, primary and secondary transducer. Third one is analog and digital transducer. Fourth one is the active and passive transducer, and fifth one is the transducer and inverse transducer. So starting with the first type of the transducer on the basis of transaction form used. So the physical effect engaged to convert physical quantity to electrical quantity, so is known as the transconduction form, to convert physical parameter into a electrical quantity, like as a gas, pressure, humidity, temperature. So these physical effects are converted into electrical form, that is known as the transconduction form, on the basis of transconduction form used. So following some physical effects or some examples are used in a physical effect transconduction form. So first one is the variation of resistance, first one is the thermistor, so there is temperature, potentiometer, so there is the resistance, then hot wire, then the hot wire meter, so then this some is heat. Next one is the variation of inductance, differential transformer, ED current gauge. These are the transducers. Then third one is the physical effect variation in capacitors. Transducer are used, dielectric gauge, capacitor, microphone are used in the transducer. Next one is the Hall effect. There we use the Hall transducer. And fifth one physical effect is the piezoelectric effect. We have to use a piezoelectric transducer. So these are the physical effects are effect to the generates the electrical quantity using this transducer. Second one is the primary and secondary transducer. So it divided into depending on the how to conversion to the transducer. So first one is the primary transducer. The diaphragm acts as a primary transducer. It converts pressure, the quantity to be measured, into displacement, the mechanical signal. So first, diaphragm is a primary transducer which senses the pressure and convert it into a displacement. So that's why diaphragm is known as primary transducer. And secondary transducer, the displacement, whatever displacement from a diaphragm output which converted it into the change in resistance using a strain gauge. So hence strain gauge act as a secondary transducer. So whatever displacement given to the strain gauge, so there is change in resistance. So the strain gauge gives a resistance or output voltage due to a change in resistance. So strain gauge is act as a secondary transducer. So diaphragm act as a primary transducer and strain gauge is a secondary transducer. Primary transducer examples: diaphragm, border tube. So these are the sense the pressure converted into a displacement. And secondary transducer examples: strain gauge and LVDT, which sense the displacement and converted into a in terms of voltage, current and resistance. And primary application, it is used for displacement and pressure. And secondary transducer, it is the mostly used in a electrical parameters. Now third one type of transducer is the analog and digital signal. So it divided into two categories. First one is the analog transducer and second one is the digital transducer. First one is the analog transducer, convert the input quantity into a analog output, which is a continuous function of time. So analog signal, it is varying with a time. So analog transducer, we sense the signal and convert it into a analog output in terms of current and voltage and resistance, which continuously varying with a time. Now next one is the digital transducer. This transducer converts the input quantity into a electrical output, which is in the form of pulses. So means their output is generated in form of pulses or in form of digital. So like as a square. So these transducer convert the input quantity into an electrical output, which is in the form of pulses. So example of analog transducer, which gives the example of strain gauge, LVDT, thermocouple and thermistor and etc. So these are the transducer use the output in terms of analog output. So and next one is the example of digital transducer, which gives the example of digital resolver, digital tachometer, photo cells, rotary shaft encoder, limit switch and Hall encoder. So these are the examples give the desired outputs in a terms of pulses or in terms of square wave or in terms of digital. So analog transducer gives the applications of temperature and displacement. Digital transducer gives the application of the light intensity, position and speed etc. So these difference between your analog and digital transducer. Now next one type of the transducer is the active and passive transducer. So we have to know the when we use the active components in transducer, then that transducer is known as the active transducer, and when we use the passive components in a transducer, that transducer is known as the passive transducer. So active transducer do not need external source of power their operation, therefore they are not self-generating type transducer. So they are require external power supply to perform their operations. So that's why it is the not self-generating type transducer. So passive transducer does not need external power source of power for their operations. So they are self-generating type transducers. So there is the energy conversion principle are used in passive transducer. So examples of active transducer: thermocouple, piezoelectric transducer, photovoltaic cell, electromagnetics, electrokinetic, electrodynamics, and pyrolytic transducer are the active transducer. And example of passive transducer: resistance thermometer, thermistor, differential transformer, photo emission cells, and Hall effect, and etc. are the passive transducer. Now we have to see in the block diagram of active and passive transducer. So first one is the measured quantity active transducer, and output is the next stage. And active transducer require external power supply. So there is external power supply block. So whatever input given to the active transducer converted into a desired output, that is the next stage block. And external power supply block given to the activate their operations and performing their operation. Passive transducer only three blocks: major, medium, passive transducer, and next stage. So whatever input given, physical quantity given to the passive transducer, will get the desired output in next stage. So that is the block diagram of the passive transducer. Applications of active transducer: light meter, solar cell, acceleration, radiation, and velocity. These are the example of the or application of the active transducer. And passive transducer application like as the temperature, pressure, speech, music, noise, force, vibration, and position. These are the number of applications of the passive transducer. Now last type of the transducer is the transducer and inverse transducer. So first one is the transducer and inverse transducer. So it depending on the type of transducer their operations. When it has a regular transducer, so it is a transducer. When it is the act is the opposite function of transducer, so it is known as the inverse transducer. So transducer convert non-electrical quantity to the electrical quantity, means physical quantity to the electrical quantity. That is known as the transducer. Inverse transducers that converts the electrical quantity to the non-electrical quantity, means the electrical quantity converted into a physical quantity. So examples like as a resistive, inductive, and capacitive transducer are example of transducers. And piezoelectric crystal, microphone, robot, and electric eye. These are the act as an inverse transducer. So some applications: temperature, pressure, speech, music, noise, force, vibration, displacement, and etc. These are the examples of transducer. And displacement, position, force, thickness, speech, and music, and vibration. These are the application of inverse transducer. Now next topic is the characteristics of transducer. So transducer has two characteristics. First one is the static characteristics and second one is the dynamic characteristics. Why these are the two types? Because of when given input is constant and it is the variable. When it is the constant, then we have to see the static characteristics of transducer, and given input is the variable, it is varying with time, so that is the known as the dynamic characteristic. It also known as the transient characteristics, and static characteristics also known as the stable characteristics or constant characteristics. So these are the two different characteristics we have to see in detail. So overall, both static and dynamic characteristics of transducer determine its performance and indicates how effectively it can accept desired input signal and reject unwanted input. So both static and dynamic characteristics of transducer are required to check their performance and indicate how effectively it can accept desired or proper input and reject or avoid unwanted signals, unwanted inputs, unwanted errors, or unwanted noise. So these characteristics are a very important role played in a selection or in a required transducer for any application. So these are the static characteristics of the transducer. So these following essential characteristics are considered for selecting a transducer for any specific application. So first one is the ruggedness. It is ability to withstand overloads with safety, stops, overload protection. So ruggedness is the very important parameter when we apply for any application with very high power consumption. So we have to check the ability of withstand overload and safety stops overload protection. Second one is the linearity. So we have to already seen the first chapter what is the linearity. So it is the ability to reproduce input output characteristics symmetrically and linearly. So whatever ideal curve and your input output relation of transducer, it is the linearly same or symmetrically same, then that transducer linearity is a good. Then second one, now next characteristics, repeatability. So repeatability means it generates a group of observations or measurements in a same environmental condition or same operating condition when a same input. So that is the known as the repeatability. It is the ability to reproduce the output signal under same environmental condition when same input is applied repeatedly. So that is the known as the repeatability of a transducer. Then next characteristics, high output quality. So it convenient device output must be larger than whatever output generated by transducer, which is the very high level or which generates the proper output than the noise, or their amplitude or magnitude is more than the noise, so you will get the high quality output. Now next one characteristics is the accuracy. What is the accuracy? Closeness of the your true value or desired value. So we have to see in the second next parameter is the accuracy, so you will get the desired output. Next one is the high stability and reliability. So if you will get the stable output, then that system is a stable. So there will be a minimum error, minimum noise in measurement system, or it is the unaffected by a environmental changes. So these two parameters, stability and reliability, is very important when we measure by using a transducer. Next one is the good dynamic response. So when input are changes, so their output is also, so we require a dynamic response are good. So whatever how much percent we have to input increase, so that much percent output are increase. So you will say that is the good dynamic response of the system. So output generation of the device with respect to function of time, which is analyzed as a frequency response. Next one is the high sensitivity, which gives the speed of response of input and output. So what is the mean by sensitivity? Changing input, changing output with respect to changing input. So how much input are changes? So we have to changes the in output. So that is the known as the speed of response, that is the speed of operating your transducer. So I sensitivity also ring. Now next characteristics is the size. So transducer should be have a smallest possible size and shape with minimal weight and volume in order to make compact measurement. Also we have to know the dynamic range. So operating range should be wide, so that should be over a wide range of measurement conditions. Next one is the excellent mechanical characteristics affect the performance of static, causes static and dynamic state. So these are the three parameters or three states affects the performance of system measurement system. So we have to require external mechanical characteristics, built-in integrated device. So when it is integrated device, so there will be a occurrence minimum noise, minimum asymmetry, and other defects are minimized. So that's why most of the transducer built in a integrated device. So these are the static characteristics are required for transducer for selecting for any application. Now next characteristics of dynamic characteristics of transducer. We have to already see the major quantity or good quantity is rapidly varies with respect to time. So the following essential dynamic characteristics considered while selection of transducer. First one is the dynamic error. It is the difference between a true values of quantity changing with time, the value indicated by the instrument, if no static error is assumed. It is also called as a measurement error. So what is the error generated in a device? So that is the desired value or true value. But here true values of quantity are changing with time, as well as their measured value also changes with time. So there is the differences between a true value or measured value, that is the generated error. So that is known as the dynamic error, or it is also a measurement error. So next one is the fidelity. So fidelity, it is nothing but the degree to which a measuring instrument is capable of faithfully reproducing the changes in input without any dynamic error. So that fidelity means how much your instrument responds with respect to a input, changes in input. So that is known as the fidelity. So there is no noise, no error. So that time you said the good fidelity of the transducer. Next one is the speed of response. So it is the operation of your transducer, how fast act with respect to input and generates the output. That is known as the speed of the response of the transducer. It is defined as the rapidity with which a measurement system responds to changes in the measured quantity. So next parameter is the bandwidth. So bandwidth is defined as the range within a band of frequency or wavelength. So it is also the amount of data can be transmitted in fixed amount. So bandwidth means how much your transducer active or perform their operation within a span or range, that is the known as the band. Now next parameter is the time lag. The time lag means the instrument changes its value after some time, even when the measured quantity changes. In this case, the response of the measurement systems begins after a dead time after the application of the input. So that is known as the time lag of a transducer. These are the different dynamic characteristics of the transducer. Thank you.